Hello students, welcome back to the series of lectures of Intermediate 1B. We were dealing with this chapter of differentiation since so many video lessons. Now in the continuation part, I am going to do for you in the same exercise 9C, the fourth bit, that is in the section 2, the fourth bit I am going to explain for you now. Those who have not watched the previous videos of this exercise 9C, just click on the I button, and the previous videos of the differentiation chapter. There are 16 video lessons. Just click on the links in the playlist or in the description below. You will be notified. Now let's quickly start here. Find the derivative of the function y defined implicitly by each of the following equations. Now till now we have done only some function and derivating some functions, but now from the fourth bit we have the equations. Some equations is equal to 0. So such equations we have to find the derivative of the function y. Asking the derivative of the function y. Now let's proceed. I have noted down two problems in this fourth one. Now let's start with this. Now we'll be derivating with respect to derivative of the function y with respect to, or obviously, x. Okay, differentiating with respect to x. That means now here d by dx of x to the power of 4, that becomes 4x cube. Okay, again dx by dx, that is nothing but 1 plus here 4y cube. Again here we get dy by dx because the function is not in x. If it is in x, dx by dx is 1. The function is in y. So we need to again derive it dy by dx minus here a square I can take common, but here two functions are there, x and y. So let us go for the product rule, u and v. Okay, so we will take this constant out and u and v. U v dash, that means dy by dx plus v u dash. U dash means dx by dx is just 1. So I have applied uv rule here and equals to derivative of 0. Constant is 0 only. This is an equation. Okay, here. Now here we will expand it. Okay, we will multiply the brackets, open the bracket and multiply it. Okay, dy by dx minus a square x dy upon dx minus a square y equals to 0. Now we will club where dy by dx are there, we will club those terms, and the rest of the terms which are not having the derivatives, that we will shift over to the RHS side. Okay, so I'll take common here dy by dx. I'm clubbing, and as well as in the same time I am taking common. So if I take dy by dx, only these two terms are there. So they are 4y cube minus a square x is equal to, these terms I will send to the other side. So this term to the RHS side becomes plus a square y, and this term becomes minus 4x square. Now here we want the derivative of the function y. Implicitly. So here we want dy by dx. So this term I'll shift it to the other side, it becomes divided. So dy by dx is equal to simply a square y minus 4x square upon this part. So 4y cube minus a square x. So this is the derivative of the y function. So from the equations also we can do the derivative part. Now moving on to the second problem. Here y is equal to x raised to the power of y here. If such problems are there when their exponential is involved, we have to go for the log values. So applying log both sides. So that becomes log y equals to here y log x according to the rules of logarithms. When there is power, that comes before. Okay, this power comes before. Now here we can apply the differentiation. So differentiating with respect to x, right? So dy by dx of log y is 1 by y. Since the function is not in x, again dy by dx equals to, there is a two functions y and log x, so we will do for u and v product rule. Okay, so that means u multiplied by v dash. V dash means the derivative of log x, that is 1 by x, plus u as it is, and dy by dx, u dash, that is dy by dx. Now the same procedure what we have done here, will bring the derivatives to one side and the other terms to the other side. Here if I take dy by dx, here 1 by y is there, common I am taking. This part, if you shift it to the other side, it becomes minus log x. Here we have y upon x only. Okay, y into 1 by x. Now here this, let me do the LCM part. So 1 minus y log x, if I take the LCM, so this is y upon x. Now we will shift to the other side. We want dy by dx. So that becomes y upon x this part, this in a fraction, that becomes reciprocal. Suppose that is y by 1 minus y log x. So that comes to y square divided by x into 1 minus y log x. So this is the final derivative, y square x into 1 minus y log x. Where exponentials are involved, we should apply log and then go for the derivating it. Okay, pause it and note it down. Here, fourth one, third bit here. Again, we have only 3 problems. So 2 problems are over. The third one, y raised to the power of x and x raised to the power of sine y. Here again we have some exponents. So when exponents are involved, we have to go for the logarithms. So applying log both sides. So that becomes, let me write log y raised to the power of x is equal to log x raised to the power of sine y. When powers are there in logarithms, we can bring it to the front. Okay, so x log y equals to sine y multiplied by log x. Okay, now here u and v, two functions are there. Now we will do the derivation. Okay, differentiation with respect to x, right? Now d by dx of this one. Here u and v, let us start with u. X, v is log y, so v dash, that is the differentiation of log y, is 1 by y, but the function is in y. Again we have to write dy by dx plus log y, v as it is, and u dash, that is 1 only, dx by dx. So uv I have done to this part, LHS part, again to the RHS part, uv function. Now this is u, so sine y as it is, and differentiation of log x is just 1 by x, plus log x as it is, and differentiation of sine y is cos y. Okay, but the function is in y, so we have to write again dy by dx. So we have 4 terms, 1, 2, 3 and 4 terms. Now where the terms of dy and dx are there, let me take common dy by dx. If I take common here, x into 1 by y, so that is x upon y, this part. From this I have taken dy by dx common, so this is again how much, log x cos y. If it comes this side, minus log x cos y, you can write it like this, equals to, here we can take it as sine y upon x. This part to the other side becomes log y. This we have taken it here. Let us take the LCM from both the sides, then we can shift it. So y is equal to x minus y log x cos y. The LCM part here also, sine y minus x log y by x here. So now we will take this to the other side, it becomes the reciprocal. So dy by dx is equal to, okay, let me write to the this side, right, let me write here. Now dy by dx, we get it as dy by dx, this part I'll write as sine y minus x log y upon x. Yes, multiplied by, here multiplied by reciprocal, so that becomes y. I'll write it down here, y x minus y log x cos y. See here, x y log x cos y. So just we will be placing them in order, that's all. dy by dx is equal to y multiplied by sin y x log y divided by this x into x minus y log x cos y. That's it. So you can write the round brackets, or else you can further simplify by multiplying it. Okay. So this is the final derivative. With this we have completed the fourth bit. Now moving on to the fifth bit. Please make a note. Now here the fifth problem. Establish the following. If under root 1 minus x square plus under root 1 minus y square equals to a into x minus y, then we have to prove that this dy by dx is equal to this part. Okay. So we have to start with this and we have to get the derivative, not like the equations where we are derivating with respect to x. Now here if you see this function, let me suppose one function as some sign and one function as some because there are two functions. Okay, so let us start. Let us suppose put, okay, x equal to sine theta. Put x equal to sine theta. Now we will take another angle. So y equals to sine of phi. Okay, I am taking this as sine phi, not sine. So this is sine theta and this is sine phi. Right? Yes. Here I am supposing x as sine theta and y as sine phi. Okay. Now we will substitute it. So 1 minus sine square theta plus 1 minus sine square phi. This is phi, angle phi. Okay. Equals to a into sine theta minus sine phi. Okay. Here. Now, this is 1 minus sine square is cos square under root. So, this becomes cos theta plus this is cos of phi equals to a into sine theta minus sine phi. Okay. Now, if you see the C and D formulas, we can apply cos C plus cos D, sin C minus sin D. C and D formulas will apply of the trigonometry. So this becomes 2 cos C plus D by 2, that is theta plus phi by 2 cos theta minus phi upon 2. Yes. Now here you can take the constant out. We can write this as 2 cos theta plus phi by 2 and sin theta minus phi upon 2. This is C and D formulas. Okay. Or else you can also write cos A plus cos B and sin A plus sin A minus sin B, those formulas. Now here, if you see in both sides something is common, here 2 is common, you can take the 2 away, and cos theta plus phi, this is common. So both sides I can cancel it off. Now what is left over? We have cos theta minus phi upon 2 equals to A into sin theta minus phi upon 2. Okay. Now if I write this to this side, this becomes tan, and this to this side, we will just cross it. Okay. 1 by A equals to just tan theta minus phi by 2. So this cos comes here. So sin by cos becomes tan. Right. Now here, if you take 1, yes, 1 upon, right. Now bring this tan to this side. This becomes tan inverse of 1 by A, tan inverse of 1 by A equal to theta minus phi by 2. Can also write it as theta by 2 minus, if you are splitting the LCM. Yes, theta by 2 minus phi by 2. Bring it to the one side. So 2 we can shift it, or else if you are not writing, if you are not here, just 2 you can shift it to this side. This becomes 2 tan inverse 1 upon a equals to theta minus phi. Okay, so phi, let me bring to this side and this part to the other side. That becomes phi. Minus phi becomes plus phi equals to, here already theta is there. I'll shift this to the other side. Minus 2 tan inverse 1 upon a. Now here we brought it, we had simplified and brought it into one term. Now what we will do, we will be writing this. What is our theta value? What is our phi and theta? That we will write it here. Let me do it here. Yes. Now phi is our sine inverse y. So that we will write sine inverse of y equals to, and theta is sine inverse of x. Sine inverse of x, right? Minus, we have minus 2 tan inverse of 1 upon a. Okay. Now we will differentiate with respect to x, because we have to establish this. By taking this, we have to prove dy by dx is something like this. Okay. So now I'll differentiate with respect to x. Differentiating with respect to x. Differentiating with respect to x, we get 1 over under root 1 minus y square. Here again we differentiation of y. Here this function is not in x, so dy by dx is equal to sine inverse. Differentiation is 1 over 1 minus x square, right? Minus this complete thing is a constant, isn't it? Tan inverse of 1 by a to everything is constant, so just we can write it as 0. Differentiation of the constant. Now here we want dy by dx, so we will write it here. Dy by dx equals to, this becomes a reciprocal, so that becomes 1 minus y square upon 1 minus x square. So we have to establish dy by dx is equal to this, right? So we have proved it, hence. So like this we will be proceeding, starting with the trigonometric functions. I have taken two angles, one is phi and another one is theta. With that we have simplified it, then we have later on we have applied the differentiation. So pause it and note it down, and with this we will be ending the class and we'll see the remaining problems of this exercise in our next class. Thank you all.